Okay, degrees, minutes, and seconds. Now, what I want to talk about is how we're going to transfer degrees, minutes, and seconds. For example, let's do 63 degrees and 45 minutes into decimals. Okay? So how do I do that? 63 degrees, 45 minutes. Sorry, not seconds. 63 degrees, 45 minutes. That's what that says. So I'm going to go back over to my lovely little calculator here, and I'm going to type in 63. I'm going to hit the pi sign. That pi sign gives me my degree key. I'm going to type in 45. Go back to the pi sign. Get the apostrophe. That's going to give you your minutes. Okay? If you can't find it there, I'm going to hit enter just to show you guys this. That gives you the radian measure. That's not what you want. That gives you the radian measure. Okay? Another way to find it is by hitting the number to the right of number 9. Right here in the second row, second column, is degrees, minutes, and seconds already. You simply type in 63, arrow to the right, 45, arrow to the right, and 0. Right there. Number key to the right of the number 9, second row, second column. Look up here. 9, second row, second column. Okay? Now, the other thing. Okay, it doesn't work. I want you to go to the book, which is to the right of 9. When you're in the book, you want to go to number 1, which is your angle. Oops, see, that's not what I wanted. Sorry. I got the wrong thing. You want to go to the book, go to number 2, and in there, you are going to see number, angle, list, matrix, vector. Okay? They open up just like they would on a drop key. If you guys look at my screen, your screen is going to look a little different than mine. Everybody look at mine. Okay? Each one of these has a different drop box to them. You want to be in the angle drop box. Okay? So once you're in the angle drop box, there's lots of different things that you can do in the angle drop box. Okay? We have degrees, radians, gradians, minutes, seconds. You keep coming down here, there's convert to DMS. Convert to DMS is degrees, minutes, and seconds. Convert to decimal degrees. Isn't that what we want? We want a decimal degree. So you're going to click on that and hit enter. And hit enter. What? You guys click on the 2. Click on the 2. Right now you're straight in full screen. You're on the arrow that back up. All the way up. Then have an angle. Open that up. Keep going down. Or you just click on it. Then you go to angle. Goes all the way down to converting. Now, if I want to go back from decimal degrees to DMS, how do I do that? I'm going to hit enter. I'm going to arrow up and I'm going to grab that number. I'm going to hit the book and I'm going to say convert to DMS and hit enter. And then it's going to give me the DMS. Do we understand how to go back and forth between decimals and degrees? Wait, arrow up. For your homework from 36 through 92? Oh, okay. We're taking it from decimals to degrees, minutes, and seconds. Sarah, do you understand that now? Okay, are we all good? Okay. Now, that brings us to what we're doing today. Circle. Get your circle out. Yesterday, we ended off with a circle that looked like this, right? It is. I mean, seriously. I am artistic. It's all good, right? It's all good, Ted. Alright, now. We can. Now, when I talked about these yesterday, I talked about a 45-degree angle and a 30-degree angle, did I not? The unit circle got filled, and we had all the values by first doing the 45-degree angles and then doing the 30-degree angles. When we did the 30-degree angles, what angles also fell out? The 60. You know why? Because what type of triangles do you have? What special triangles do we have? A 45, 45, 90 triangle and a 30, 60, 90 triangle. Do we understand that? That's where these things come from. Okay? Now, there's a theorem. Do I expect you guys to remember it? You should have remembered it from geometry, but I'm not going to lie. Many of you are not going to, and I'm going to be absolutely ridiculous if I try to make you memorize it. A 45, 45, 90 triangle says, in a triangle, in the 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. But here's what you need to know about. Our leg is going to be our lovely little radius. Well, what is our radius of our circle? 1. 1. Okay? So I'm going to yes, I am. If I have my triangle here, okay? This is the leg, this is the leg, this is the hypotenuse. How do I know the longest side of the hypotenuse? It's across from the 90-degree angle. Do we all understand that? Well, if this is 1 and this is 1, then this has to be the square root of 2. Do we all understand that? Yes or no? By this definition of a right triangle. Now, have we all heard about SOHCAHTOA? You guys learned SOHCAHTOA back in Algebra 1, back in the day whenever they first introduced trig functions to you with using proportions, right? Now, what this is it's saying that your sine value is equal to your opposite leg divided by your hypotenuse. Your cosine is going to be your adjacent leg divided by your hypotenuse. Your tangent is going to be your opposite leg divided by your adjacent leg. Now, that should bring you to a few terms that you need to memorize. Opposite is what? What does opposite mean? Directly across from the angle. Do we understand that? What does adjacent mean? What is it? It's directly beside the angle, forming part of the angle. Do we understand that? Okay? So, if I'm looking at this, I'm going to put an angle right here. This is going to be theta. If I want the sine of theta is going to be your opposite over your lovely hypotenuse. This would be your adjacent. Do we understand that? So what's going to be your opposite leg? Over. Now, what is big? Can I ever have a radical in the denominator? No. So how do I rationalize this? I multiply by what I need to get rid of that to give me the square root of 2 over 2. Why is that the square root of 2 over 2? Because the square root of 2 times the square root of 2 is the square root of 4. What's the square root of 4? 2. 2. So the sine of theta is going to be the square root of 2 over 2. Now what's the cosine of theta? Now I should have told you this just to make sure. I'm going to erase theta here. Because theta is not generic in this case. Theta is a 45-degree angle. Why is theta a 45-degree angle? because I'm using the 45, 45, 90 triangle here, right?
Yeah.
Okay? So the sine at 45 is going to be the square root of 2 over 2. The cosine at 45 is going to be adjacent, which is going to be 1, over the hypotenuse, which is the square root of 2. So give me the square root of 2 over 2 again. Now what would the tangent be of 45? Tangent of 45 is going to be your opposite leg over your adjacent leg. So what's your opposite leg? Over your adjacent leg? To give you a tangent of 45 degrees being 1. Now what am I going to do with that information? I'm going to go right back to my circle. I'm going to go right back to my circle. Okay? And this is your 45 degrees, right? What was the equivalent of 45 degrees?
Pi over 4.
Pi over 4. Right? Now I'm going to add 45 degrees to that. That's going to give me 90. Which means I'm going to add pi over 4 to that. That's going to give me pi over 2. I'm going to add another 45 degrees to that. That's going to give me 135. So I'm going to add another pi over 4 to that. That's going to give me 3 pi over 4. I'm going to add another 45 degrees to that. That's going to give me, which is the same thing as pi. I'm going to add another 45 degrees to that. That's going to give me 225. And that's going to give me adding another pi over 4. I'm going to add another pi over 4 to that. That's going to give me 6 pi over 4, which reduces down to 3 pi over 2, which is the same thing as 270. Add another pi over 4 to that. 315, which is going to be 7 pi over 4. Add another 45 degrees, it's going to give me 0, which is 360, which is going to be 2 pi. Okay, now I went through this with you again because I want you to understand how to get those. Okay? Now, what I want you to understand about sine and cosine. Sine and cosine values is just an ordered pair. Cosine, comma, sine. Meaning x, comma, y. Do you understand that? So every time you see cosine, that's the same value as your x coordinate. Every time you see y, that's the same value as your sine coordinate. Do we understand that, yes or no? Now, if I gave you the sine and the cosine, the sine was the square root of 2 over 2, the cosine is the square root of 2 over 2, I need to make an ordered pair on my unit circle. So the ordered pair that I'm going to make on my unit circle is now going to be the square root of 2 over 2, comma, the square root of 2 over 2. In other words, the x-coordinate corresponds to the cosine, the y-coordinate corresponds to the sine value. Yep, that's where it goes on your unit circle.
Now, why is that?
It goes, you have to memorize that because we are corresponding this, we're plotting this on an xy plane, right? So if you were to put this there, you're going to draw a 90 degree or a 45, 45, 90 triangle. At a 45 degree angle, you're going to come to the point at the square root of 2, comma 2, the square root of 2 over 2, comma the square root of 2 over 2. That's going to be the point. That x represents the cosine, that y represents the sine, every time. Okay?
So it's
For every degree.
Now, that's in quadrant 1. In quadrant 1, my x value is positive, my sine value is positive. Now, in quadrant 2, what do I know about my cosine and sine? It's negative positive. So anything that has a denominator of 4 has exactly the same ordered pair to it every time. It doesn't change. What does change is the sign values of it, meaning is it positive or negative. So when I'm in quadrant 2, what turns out to be negative? Negative 2 over 2, comma, positive 2 over 2. Because that's going to deal with the x-coordinate changing. Do we understand that?
Yeah.
In quadrant 3. In quad 3, what do we know? That they're both negative. So do I have a denominator of 4 down there?
Yeah.
Yes. So therefore, what's my sine and cosine?
Negative.
Negative square root of 2 over 2, negative square root of 2 over 2.
So these go right with the 45.
Those go right with the 45. Now I'm in quadrant 4. And in quadrant 4, what do I know?
Positive, negative.
That I have a positive, negative quadrant. So that means, do I have a denominator of 4 there?
Yeah.
Yes. So what's that point going to be?
2 over 2, negative 2 over 2.
Negative square root of 2 over 2. Do we see that, yes or no? So do you know the first quadrant? Do you know all the other ones then? Absolutely. Now, let's go right back to our lovely thing of this, right here. We're aware. Now, we're in a 30, 60, 90 triangle. Same concept. Exact same concept here. Okay, except for now we have two different angles. We have our 30-degree angle up here. We're going to have our 60-degree angle down here. Do you see that, yes or no? This says in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. Well, the hypotenuse is going to be opposite the right angle, which is going to be 2x. And then the shorter, and the longer leg is the square root of 3 times as long as the shorter leg. Well, where is the shorter leg at? The shorter leg is going to be attached to the 60-degree angle. Do we all understand that? So the shorter leg is right here, attached to it, which gives me x. Do we all understand that? And then the other angle, the other leg is going to be x times the square root of 3. Do we all see that, yes or no? Now, what does x represent here? What does x represent here? Why is it 1? Because the radius of the circle is 1. So therefore, what I have going on here is not 2x, but 2. Not x, but 1. Not x times the square root of 3, but the square root of 3. Do we all see that, yes or no? Yay, nays? So now, we're going to do 30 degrees. The sine at 30 degrees. So if I'm going to do the sine at 30 degrees, what is sine again? Opposite over hypotenuse. So what is the opposite leg of 30 degrees? Opposite leg. 1. What is the hypotenuse? 2. So the sine at 30 degrees is going to be 1/2. Cosine. Cosine at 30 degrees is equal to what? What's cosine equal to? Adjacent over hypotenuse. What's adjacent to 30 degrees? The square root of 3. And what's the hypotenuse? 2. Okay, well now I'm going to do the other leg. I'm going to do, or the other angle, the sine of 60 degrees. But what's the sine of 60 degrees? What's sine again? Opposite over hypotenuse, so the opposite leg is going to be square root of 3, hypotenuse is going to be 2. The cosine of 60 degrees. What's the cosine going to be? Adjacent is going to be beside it, which is going to be 1, and the hypotenuse is going to be 2. What do you notice about 30 and 60 degrees? They're opposite of each other. Is that very easy concept to remember? They're the opposite of each other? Okay, well now what's the tangent of 30 degrees? The tangent of 30 degrees. Well, tangent's going to be opposite over adjacent. Opposite 30 is going to be 1. Adjacent is going to be square root of 3. And if I rationalize that, what's that going to give you? Square root of 3 over 3. The tangent of 60 degrees. What's that going to be? Opposite over hypotenuse. What's the opposite?
Opposite of hypotenuse.
Opposite over adjacent. Sorry, my bad. Over 1 to give you just the square root of 3. Now again, what do you notice about the tangents of 30 and 60? They're opposites of each other, right? Okay, so now what we're going to do is we're going to form the ordered pair for my 30-degree angle. So if I come back over to my 30-degree angle, which I'm going to use this one because we don't have much time. Okay? If I come over here, I'm going to put my 30-degree angle on here. Everything that has a denominator of 6 is 30-degree angle. Agreed?
Wait.
Every single angle that has a denominator of 6, remember the 30-degree angles hover around the x-axis, the 60-degree angles hover around the y-axis, right? So, the 30-degree angles are going to be the ordered pair what? What was the cosine? And what was the sine? 1/2. Then I'm going to go over to the second quadrant. Which one has a denominator of 6? The 5 pi over 6. But this time I'm in quadrant 2. So what's going on here? Negative square root of 3 over 2, comma 1/2. Okay, now I'm in quadrant 3. What's that going to be? Negative square root of 3 over 2, negative 1/2. Now I'm in quadrant 4. What's that going to be? Positive square root of 3 over 2, negative 1/2. That gives me all my 30-degree angles. Now how do I come up with my 60?
You go,
It's opposite. So that's going to be the 1/2 comma the square root of 3 over 2, right? Now I go over in quadrant 2. What's going to happen in quadrant 2? Negative square root of 3, sorry, 1/2. Square root of 3 over 2. I come down here to quadrant 3. What's this one going to be? Negative 1/2, negative square root of 3 over 2. I come over here to quadrant 4. What's this one going to be? 1/2, negative square root of 3 over 2. Do you see how we ended up with the unit circle? So what you're going to have on your unit circle is going to be this jump.
That looks worse than what I wrote.
Well, you all know where they came from now, right? Okay, have a great one. What do I expect you guys to do tonight?
I have another one.
Study on that.
Yeah,
If anybody wants a new unit circle, you can have
Oh,
one.
sorry. You didn't even grab one for me?
No.
I gave you one.
I know.
Wow, that's
Wow,
I stole it.
that's tough. I don't even know why I get stuck.
So I have this mark board in my room, and my mom makes post-it, like, note cards, and she put tape on the back of them, and she makes me go through and put them